In the previous video, we completed a non-compartmental analysis for single ascending dose study data and exported the raw result file. Now, we will use this file to perform a dose proportionality analysis. Let's get started. First, we need to upload the raw result file we exported earlier. Click on Upload a dataset, select the result file, and upload it to the study dashboard. Once uploaded, click Run a new task. Name your task to reflect its purpose, such as single ascending dose, dose proportionality, or we can call it just SADDP. Select dose proportionality as the analysis template and click Next. In step 2, choose the dataset you just uploaded. This dataset contains the raw result from our previous NCA. Click Next to proceed. In step 3, you will map the variables required for dose proportionality analysis. The primary variables needed are ID and amount. Other columns will be used as parameters for dose proportionality. The system should automap these variables based on your dataset. There are 6 steps in total, but you can directly proceed to step 6 to view the results. For now, we will review each step in sequence. In step 4, examine the parameter summary table and parameter listing table. You can also view parameter versus dose plots like those in NCA to understand if there is a linear increase in exposure and to check if this increase is associated with increasing dose. So basically, we are evaluating if there is a constant clearance over the same dose interval. In step 5, configure your dose proportionality preferences. You all know that to quantify deviations from dose proportionality for any dose demands the use of statistical models. Parameters can be estimated with measures of imprecision, usually confidence intervals, and dose proportionality is characterized by model parameter values. Assuming log normal distribution for exposure related parameters and dose as a fixed effect, we use the power model for this analysis. Beta is the slope here. You can also select the reference dose and confidence interval. By default, the first dose is chosen as a reference and 95% confidence interval is set as default. You can also choose which parameters to analyze for dose proportionality. Default options include Cmax, AUC last, and AUC infinity observed, but you can also select other parameters if needed. Proceed to the final step, that is step 6. Here, review the dose proportionality results. You can view two different tables over here, the power model results and the ratio test results. The power model results include the slope estimate and their 95% confidence intervals. Values of beta above 1 represent high exposure or super proportional. Values of beta below 1 represent lower exposure or subproportional. Additionally, the power model results for parameters like Cmax, AUC last, and AUC infinity observed are plotted with geometric mean and observations overlaid. The equations for these models are displayed at the top of the figures. Beside the power model, the ratio test results compare each dose to the reference dose. The ratio estimates in the 95% confidence intervals are shown in these tables. And expand the other accordions for AUC last and AUC infinity observed to view detailed dose proportionality analysis results. To summarize, we used the raw result file to perform dose proportionality analysis, reviewed the results from both the power model and the ratio test, and explored the visual outputs. If you are interested in a combined workflow starting from NCA to dose proportionality analysis, watch the next video where we'll cover that in detail. Thanks for watching.